Good morning, everybody, and welcome to our event this morning. My name is Paul Parkinson from the Supply Chain Sustainability School in Wales, and we're delighted to have you here today. First up, just a bit of housekeeping. We've got a big audience, so your cameras and your microphones will be muted using this platform. However, if you do have any questions, please do put them through the chat facility. We'll do a Q&A at the end. So we will be working through them and picking some out to help us do that at the end of the session. And of course, we'll distribute the slides after the event. But it's great to have so many people here so far today. And we should also point out that the event is being recorded. So just please be mindful of that. We've got a packed agenda. We've got Laurie from Concrete Canvas, we've got Catherine from Rockwall, we've got James from Wood Knowledge Wales, and Owen from Seltzer UK. But first up, I'm just going to hand over to the chair of the school in Wales, Wyn Pritchard, just to set the scene for the day. Thank you, Wyn.
Thank you, Paul. Good morning, welcome. Bore da, croeso I pawb. As Paul said, my name is Wyn Pritchard. I'm a proud chair of the Sustainability School in Wales. And I'm also a board member of the Optimised Retrofit programme, which some of you might have heard been announced by Welsh Government around 6 months ago. This is really linking the carbon reduction policy in Wales very well in terms of where we move forward. But I think the programme today, the 4 segments, the overall topic, carbon reduction in Wales, is critical and a key policy element of Welsh Government. There are a number of targets and reports you've all seen and all been made aware of that have been reduced over the years. But I think now is the time for action. There's future generations, as I mentioned, the optimised retrofit and modern methods of construction are really changing the way the industry, and I'm talking wider than construction, needs to change. I am really pleased to have the 4 excellent speakers that we have attached to the meeting today, because they will highlight the carbon reduction agenda from diverse fields of expertise. And I think the wide cross-section we have brought together today will really give you an excellent insight as an audience. But enough from me. Back over to Paul to hand over the day and enjoy the presentations.
Thank you, Wyn. So first up is our colleague, Laurie, from Concrete Canvas. Laurie, take it away. Thank you.
Good morning, all. Thank you for that great introduction. Okay, so I will be presenting the Concrete Canvas erosion control material from Concrete Canvas Limited. My name's Laurie Cummings. I am the technical representative for Concrete Canvas Limited, and I cover Wales and the southwest of England, so all the area that you see in red. Now, Concrete Canvas, the company, shares the name with the material, so there's a distinction to be made. I personally am a member of the Institute of Civil Engineers, and recently our president, Rachel Skinner, spoke about the need for reduction of carbon within infrastructure. And when you look at one of the areas where carbon is emitted, it's in the use of concrete through the production and installation use and then removal of concrete from site. So really, when we look at construction, we should also be looking quite closely at our use of concrete. You can't escape the use of concrete. You're going to need concrete. It is the most common construction material, the most used construction material. So are there innovative materials out there, innovative uses of concrete that will allow us to reduce our dependency on it and reduce the actual amount of carbon-rich material, i.e. concrete, that we use? And that's what I will be touching on when I talk about concrete canvas. So concrete canvas itself, the material, what is it? Essentially, it's a flexible fabric, okay? It will arrive on site in this flexible form and is filled with a cementitious mix. Once it's hydrated, after 24 hours, it will set to form a thin, durable concrete surface, okay? Now, the primary use of concrete canvas is for erosion control. and it's used across the civil engineering industry, from the rail to the road sectors, public works, so you're looking at your local councils, and across into the mining and petrochemical industry. So there you can see in the presentation what concrete canvas is. It's cut through the material. We also manufacture concrete canvas hydro, which combines, the erosion control solution, which is concrete canvas, with that blue hydrocarbon resistant geomembrane backing. Now, that means that the concrete canvas hydro material can be thermally welded to give an impermeable, totally waterproof barrier, and it's used for containment. Okay, so when we think about concrete canvas and its applications, it's used for rapid channel lining, okay, slope protection, it's used for bund lining in the petrochemical industry, it's used for concrete remediation, so relining old concrete assets, and weed suppression. And here's a list of the other applications that it's used for. As you can see here, culvert repair right through to cable covering and protection. So moving on to the sustainability credentials of concrete canvas. In 2020, we commissioned Ricardo Energy and Environment to conduct a life cycle analysis of the concrete canvas material and compare it to ST4 poured concrete. Now, ST4 concrete is a widely used strength of concrete on site, okay? And typically it could be installed on a channel for channel lining purposes. So we got Ricardo Energy to look at the life cycle analysis from the sourcing of the materials, our upstream carbon footprint, compare it to ST4 poured concrete for channel lining at typically 150 millimeters thick of the traditional concrete, and compare the carbon analysis and the global warming potential during its installation right through to its removal and end of use. So essentially, the concrete canvas material is 8 millimeters thick. It can be as thick as 13 millimeters and as thin as 5 millimeters. Our most commonly used material is the 8 millimeters thick. We compared it, and the Ricardo Energy report found that using an 8 millimeter thick concrete canvas material would give you a global warming potential saving of up to 55%. That's because the material you will save on using a carbon-rich product that is concrete, because you use physically less concrete. When the material is only 8 millimeters thick, it's pretty obvious that compared to 150 millimeter thick ST4 poured concrete, you're not going to need that much material. Also, and more to follow on the user benefits of concrete canvas, you've got a very low logistical footprint. You can fit more concrete canvas on a vehicle than you can on than you could for an ST4 poured concrete. Even if you were to reduce the amount of traditional concrete on site, you would still realize savings when using the concrete canvas material. So continuing with the sustainability of the material, you've got our typical clients, there's a range of them, but we've been specified on a number of natural resources Wales projects, and this one was the Cynrig hatchery in South Wales. And you can see here the channel that was lined with concrete canvas over time will take on a greener appearance. It will blend into the environment. You've got the environmental bodies such as Natural Resources Wales specifying the material because they realize it's got a lower carbon footprint and it's also a sensitive material for the environment. And this particular project was right next to the Cynrig salmon hatchery south of Brecon. Just quickly touching on the profile, we're a Welsh company. We're based just off or just outside of Pontyclun, just off the M4. We're situated at our latest factory where we've renovated the factory. In terms of sustainability of the workforce, the majority of our workforce live in the Rhondda Cynon Taf Council. We're an excellent employer of local workforce, but we are also an internationally based company. As can be seen here from the global map, as of last year, 80% of the material was exported to over 80 countries across the globe. Our clients are numerous, but within the local area, I've worked with the South Wales Trunk Roads Agent, North Wales Trunk Roads Agent, Natural Resources Wales, Welsh Water, and a myriad of local councils and unitary authorities. The local contractors that we work with, you've got your Alan Griffiths, your Waters, your Jim Davis. There's quite a few local Welsh-based contractors that we work with that recognise the value of the material. And this was just a snapshot of some of the councils that I've worked with just locally here in the Vale of Glamorgan, ranging up to, you know, Anglesey Council, who I presented to last week, as well as the North Wales councils such as Gwynedd, where we've installed on the A55. So as a reminder, the concrete canvas material is an erosion control material, and we also combine the concrete canvas material with a hydrocarbon resistant geomembrane backing, which can be used to contain liquid. The material will arrive on site in either bulk roll format, as you can see on the left, or batch rolls or wide rolls. And essentially, this is where you start realizing your sustainability and your carbon reduction, because the amount of material contained within a roll lowers the logistical footprint, because you need less plant on site and you can transport more of the material than traditional concrete solutions. We're very happy to hold our BBA certification, which means that we are, in terms of longevity, the material, when installed for channel lining or bund lining or slope protection, will have a design life of 120 years. So in terms of sustainability, you don't need to go back and replace the material and therefore increase your carbon footprint, increase your transport costs, use more fuel. You can install the material and leave it there for longer than you would be able to if you were using, for example, poured concrete or concrete channel sections or slab concrete or sprayed concrete. So moving on to key user benefits, we're rapid to install, up to 10 times faster than conventional concrete. We're also very easy to install. You don't require specialist contractors, you don't require specialist training. The low logistical footprint is a key advantage as well, and you can install concrete canvas in wet weather. So this schematic that you see in front of you is a comparison. You've got on a pallet our 8mm thick CC8 material, which will cover 120 square meters. If you were using the equivalent poured concrete, spreading it over at 150mm thick, you would need 2 6-ton concrete wagons on site. So when I say you reduce the logistical footprint, that has an impact on your CO2 emissions, because you don't need to transport and emit a lot of CO2 emissions on the road. And also you just look at the sheer amount of concrete material being used when you compare concrete canvas to traditional concrete. One palletized load as opposed to 2 6-ton ready-mix concrete trucks. You can install the material in the wet, so you don't have to lose time waiting around on site for better weather. The material has a 2-hour window. Once it becomes hydrated, it will start to set after 2 hours. So it will also set underwater, so you'll also save time on site. You will lower your project costs because of the speed of installation. This was MJ Church on the south, in South Wales, on the Church Village bypass. They used concrete canvas as an alternative to riprap lining, which is, for those of you that know, is typically a stone sort of lining with concrete, where you would use it to prevent erosion of a channel. That would have taken them 3 days, a lot more concrete, but they managed to line this channel in an afternoon and make up 2.5 days in their program. And then finally, the fourth key user benefit is the eco-friendly nature of the material. I've touched on the fact that you will use 90% less material when using concrete canvas. It's transport efficient, and appealingly, it's got a low washout rate and a low alkaline reserve, which means that when you install concrete canvas and hydrate it, the washout of that of the material will not alter pH levels of local and adjacent watercourses, which means that the local flora and fauna are not going to be affected when you install next to a river. Okay, to conclude, I'm going to touch on 2 Welsh case studies that highlight the effectiveness and the sustainability credentials of concrete canvas. So this excuse me, sorry, this one is up in Scotland. The reason why I'm highlighting this is because concrete canvas was used to reline an old concrete channel. The client was Scottish Water, and they had a 1.5 kilometer long channel that over time had become basically cracked. As you can see, there was vegetation growing in the channel, and they were losing a lot of water, and every year they were spending tens of thousands of pounds through maintenance. And that has knock-on effects of, increased carbon footprint when you keep installing concrete, or you keep having to mobilize a workforce to get to site. It was a remote site. So they wanted a solution that saved on maintenance primarily, but also meant that in the long term, they would not have to return to site. The canvas was installed across the existing channel. Before they installed it, they removed all the vegetation and made sure that there were no large voids in the channel. And then our 5 mil thick CC5 was installed across the channel, as can be seen here. Now, the great thing with the material is that it's a thin material, as opposed to traditional concrete, which would maybe be 100 mil thick. This material, concrete canvas, didn't alter the internal capacity of that drainage channel. It also provided, as I've spoken of before, a design life of 120 years. As a result of installing the concrete canvas material, Scottish Power reduced their maintenance costs, which were before tens of thousands of pounds. They reduced their carbon footprint because they don't have to keep adding traditional concrete to repair the channel or mobilize their workforce and travel to site. And you can see that for all intents and purposes, the concrete canvas material is as the previous concrete channel. It provides the same protection, and it was incredibly quick to install, up to 800 square meters in a day. This was a photo taken 4 years after installation. No maintenance has been required. You can see from the watermarks the amount of water that travels in the channel. Okay, so they didn't have to return back to deveget and to maintain it, and they would have therefore reduced their carbon footprint. This is a Welsh case study. This is bund lining. So over in Milford Haven, you've got the refinery site. One of, I think it is the largest refinery site or oil terminal in the UK. Now, concrete canvas can be used to upgrade the secondary containment berms that are installed around the perimeter of the primary containment tanks. Now, due to regulatory basically regulations, it means that these bunds must not be vegetated due to fire risk. The bunds must also be maintained at a regular height, but over time, due to wind and water, vegetation, burrowing animals, these bunds will begin to degrade. And you can appreciate that if you keep returning to remediate the bunds, build up the bunds, there's a carbon footprint over time. There's also maintenance, continued maintenance that would be required. Now, a solution is to line these channels with concrete canvas. In 2017, 10,000 square meters of our 5 mil thick hydro material was installed. Now, the hydro material not only provides erosion protection, rapid erosion protection, it also provided a totally impermeable barrier, which meant that any spillage of whatever's contained in there, your oils, your diesels, your whatever hydrocarbon is contained in the primary container, would be stopped and completely held by the CC hydro material. In terms of sustainability, you've got a totally reduced maintenance aspect to the product. Once that material is installed, you don't need to do anything further to it. You've got no UV degradation, so it won't degrade due to sunlight, it won't degrade due to weather, and it's there for all intents and purposes 120 years. The project itself was awarded, I think, in 2017 an Institute of Civil Engineers Innovation Award due to the innovative way that they installed the material. And to all intents and purposes, the it was Sem Logistics who had control of the site, but Valero now have control of the site. It is a recognized alternative to a geosynthetic clay liner, so your bentonite clay liners. Concrete canvas outperforms, in our opinion, traditional solutions because you don't need to protect the material once it's installed. It's a lay it, install it, leave it solution, and it's a one-stop solution. So that brings me to the end of my part of the presentation. If you have any questions, I think we're taking them at the end. Thank you very much, and hope to speak to you at the end.
Thank you, Laurie. That was absolutely fascinating, I must be honest. I think someone in the chat function has called it the magic carpet, which I think is very apt. We will do the questions at the end and we'll pick them out. Just one quick one. Presumably it's being used on the European mainland and over in the Republic of Ireland and Northern Ireland and such.
Certainly. It certainly has been. I'll just bring up this slide. You can see every country in blue is where concrete canvas has been sold. We have 10 international business development managers that are responsible for Europe, rest of the world. It's a very attractive material for certainly industrialized countries that want to be protecting their assets, that don't want to return to site year after year, and it's a great asset and a great showcase for what can be done here in Wales. It's an international company with strong local Welsh links, as I am testament because I am the Wales representative.
That's fantastic, because one of the things that I perhaps missed out right at the start of the presentation was to say we've chosen Wales-based companies today because we want to try and promote sustainable materials, sustainable processes that are developed, used in Wales, employ Welsh people, and to help create supply chain resilience across Wales as well, because supply chain resilience is a big thing at the moment, but particularly post-COVID, or if we are post-COVID, which I don't suppose we are. I suppose the things that I picked out of it, Laurie, were straight away, I think, right, okay, I'm not pouring concrete on site, so it's safer for all concerned.
It certainly is.
Presumably there's less waste as well. Less spoilage.
So the bulk or batched rolls that the material arrives on site. So here you can see on the left there's the bulk rolls. That means you would just cut the material that you require. So you don't have to worry about, for those of you that are in the industry, lots of the time you order part loads. Your concrete will arrive on site in a part load, and sometimes you don't want to have a part pour. You want more concrete. You don't want a partial set. So you would order typically more concrete than you would require. However, the concrete canvas material means you cut the material to size that you want on site.
Wonderful. Thank you very much, Laurie. That was a really good presentation. Absolutely excellent. Thank you. If I just move down the slides a little.
I'll put us back to where we were. Sorry.
If you would. Thank you. Brilliant. Okay, thank you. So next up is Catherine James of Rockwool to talk ostensibly about science-based targets. Again, another Wales-based organisation. Please do send your questions through to the chat and we'll put them together for the Q&A right at the end. So over to you, Catherine. Thank you.
Thank you very much, and good morning, everyone. Just going to give you a quick overview of Rockwool if you're not familiar with who we are. So we're a global organisation founded over 80 years ago. We've got 45 manufacturing facilities in 39 countries across the world. Our UK base was founded in 1979. We're based in Bridgend in South Wales. And most of what we do in the UK is manufacture insulation from volcanic rock. The inherent properties of that material are thermal and acoustic performance, and it's also naturally non-combustible. So Rockwool itself is a family of brands. So we've got Rockwool, which is the insulation material that you may be more familiar with. We've also make horticultural substrate, cladding board, ceiling tiles, and engineered fibres for acoustic control and for water management. So quite a wide variety of uses for stone wool. This presentation is focusing on our target setting, why it's important to us, and how to succeed. I'm going to cover basically target setting as part of your purpose and culture of your organisation, robust data and how important that is, top management oversight of targets. If you haven't got that sort of push from the top, it's going to be much harder to make those targets stick and to meet them. Collaboration, we can't do it all ourselves. And then I'm going to just briefly go into what our targets actually are and what they mean for us. So our sustainability strategy focuses on the UN Sustainable Development Goals. So there's 17 of those, of which we've selected the 10 that we can make a real material difference to. So our products positively contribute towards all 10 of those goals, but we also recognise that our operations have a footprint, and therefore we've set 6 operational targets also aligned to the goals to minimise that impact. So as I mentioned, we are a family of brands, so where you may not think of sort of zero hunger and clean water as necessarily being an insulation business's job, we do make that horticultural substrate. So this goes across the globe and across all of our brands. So everything we produce helps to combat climate change in one way or another, grow the circular economy. That's a cool part of our business, or safeguard citizens' well-being. And all of our operational goals are aligned to those aims. So just reflecting back on our recipe for success that I put a few slides ago, the purpose and culture. So sustainable is integral to our business strategy. The robust data, we pursue fact-based, auditable approaches backed up by third-party reference methodologies. We don't stick our finger in the air and have a guess at where we need to be. We look for the kind of gold standards out there. Those are the ones that we align to. The Sustainable Development Goals being core to our sustainability strategy, and more recently the science-based targets that we've attached our decarbonisation goals to. For the last reporting year, the performance against our 6 sustainability goals has been verified and assured by an external party for the first time. So that's sort of feeding back into that robust data, the sort of assurance that we're not kind of policing ourselves, we're putting it out there for third parties to do that job, and also collaboration. Like I said, we can't do this all ourselves, so we're looking at the best practice out there, getting on board with that. So slightly out of order, because on the next slide I'm going to sort of mention what who the Science-Based Target Initiative are. But there are currently around 1,000 companies that have made a commitment to set science-based targets, and around 500 of those have gone through the approval process. So most of those companies tend to be financials and real estate. They're low energy intensive. Rockwool would be considered an energy intensive company in terms of our production. And those kind of companies are sort of very much in the minority at the moment. We sort of got a top 10 in that diagram on the right. Construction and engineering coming in at number 13, construction materials 21, building products 22. So there's only 11 companies at the moment that are engaging with the Science-Based Targets Initiative. And these were the questions that we asked ourselves in the setup. So what are the Science-Based Target Initiative? Do they have credibility in their setup, their governance and approach? So they're a not-for-profit partnership between the Carbon Disclosure Project, the UN Global Compact, World Wildlife Fund, and the World Resources Institute. So I think there's a huge amount of credibility in terms of who they are and how they conduct themselves. What is the science behind science-based target trajectories? So that they pull together resources to provide technical assistance to companies engaging with the initiative. They define and promote best practice in emissions reduction methodologies. There are a number of kind of metrics along which you can align your targets. There's sort of 2 degrees, well below 2 degrees, and 1.5 degrees as set out in the Paris Climate Agreement. Our trajectory aligns with the well below 2 degrees endpoint. So how are emission scenarios allocated? Is there flexibility? I'll come back to why that's important in a couple of slides. What are the targets relative to? What are they going to achieve? And we want to see examples of companies like us. There aren't many of them, as I mentioned on the previous slide, but we weren't the first to go down this path. And what was the process post-validation? What would happen if we went off track? How do we account for acquisitions? You know, these are 15-year targets. There's a lot that can change in that time. And what information gets published? And we'd had, you know, we sort of satisfied ourselves that we were sort of aware and comfortable with the processes here. So Rockwell itself considers ourselves a carbon negative company. There's a building installation that we sold in 2020 will save 100 times the carbon emitted and energy consumed in its production. Now we have used in production. We're actually talking about the extraction and transport of raw materials, as well as the actual manufacturing process itself. We're big supporters of life cycle assessment and environmental product declarations. In the last few months, we've had an update to our environmental product declaration for our production facility in Wales. Since 2016, we've reduced the life cycle embodied carbon of our product by 28%, which is something we're incredibly proud of. But we're looking to, you know, across our globe and family of brands, we want to decarbonise our business and our value chain. So in December of last year, we set 2 science-based targets to reduce our scope 1 and 2 emissions by 38% by 2034. So scope 1 and 2, the sort of combustion fuels that we use on site, and also the kind of embodied energy of the electricity that gets supplied to site. And our sort of non-factory absolute life cycle greenhouse gas emissions, so our scope 3 emissions by 20% by 2034. Now, what is particularly important about the way we structured those goals is that we know through life cycle assessment and through our environmental product declarations, the majority of our impact happens in the production phase. So our scope 1 and 2 emissions, reducing those will have an enormous impact on the embodied carbon of the product. So what that comes to is a sort of 1/3 reduction of Rockwell's life cycle greenhouse gas emissions in 15 years. Again, an important point to note, that's greenhouse gas, not just carbon dioxide. So if you take methane, for example, has got 20 times the potency of carbon dioxide. So it's really important to tackle all of the greenhouse gases that can contribute to climate change. At the same time, we've got our operational target about reducing our carbon intensity, so that's the amount of carbon we emit per tonne produced of our production, and that's sort of running alongside the science-based target with an endpoint of 2030. The science-based targets will run from 2019 to 2034. Now, I mentioned about the sort of trajectory, and decarbonisation is not going to be a linear process. I mean, for our perspective, you know, we've made a number of changes over the last few years. I mentioned that 28% reduction in our embodied carbon over the last 5 or 6 years. The big changes are going to come through changes to melting technology, and you know, some of the technologies that are going to be needed to achieve science-based targets and ultimately the sort of net zero targets by 2050 may not have been developed yet. But the goal setting is important because it means that we've set out where we need to go. We know where we are, where we need to be, and then we can start to plan what changes can happen over time. So we've got our group technology and research and development departments who are working on new melting technologies, and when they come in, they'll sort of bring about these big drops in carbon emissions. And then maybe nothing else that happens for a couple of years. These are huge capital investments. We've got 3 production lines, 3 furnaces. You can see that we're sort of gradually sort of build up to another big capital investment and have another big drop in carbon. So you may sort of see for the first couple of years, it doesn't seem like an awful lot is happening, but there will be an awful lot of front end engineering studies, feasibility studies, building up to the actual installation of these new technologies. And then we get the big drop, and then again, you get a couple of years where there's a lot of planning going on behind the scenes, but you won't see any sort of dramatic falls. But what is important is that, over that timeline, that we do get to that end point. We've got trust in the methodology, the way that we can report against it, that it is transparent, and we will be held accountable should we not be meeting those targets. And we're going to be looking at how our business processes might be restructured to promote success. We may look at including KPIs in performance reviews, for example. So, holding people's performance relative to our sustainability targets as important. We may adjust our payback and investment periods, and that's something that's already happened. So we've got sort of standard payback and investment timelines for most capital projects. Those have been extended for any project which contributes towards our sustainability goals. So we give them a bit more leeway and allow more time. And so I focus today on decarbonisation and our science-based targets. There's an awful lot more going on with sustainability. I mentioned circular economy. That's a huge part of our sort of strategy and the way that we do business. We make a recyclable product. We incorporate waste from other industries in our product as well. And you can read more about that in our 2020 sustainability report, which is available on the group website now. Thanks very much.
Thank you very much, Catherine. That was really, really useful and really, really helpful, I'm sure, to everyone who was listening. I think from my point of view, I think sometimes people come up with, the phrase science-based targets. And sometimes I think actually we just need to take a step back, demystify it a little bit, as you've done there. And if anyone wants to understand science-based targets better, there's lots and lots of resources on supplychainschool.co.uk, which can help in a really straightforward and easy way to explain what science-based targets are. And I have so many questions for you, which I'm going to save to the end, if that's okay, Catherine.
Yeah, no problem at all.
In targets and why you think it's driven you, and we'll come to that at the end, and we've got some in the chat as well. But you are, as we wanted to promote, you are a Wales-based organisation, really focused on carbon reduction, as we've seen there, and we've got loads of resources on the site that can help all of the people who are here on the call today. So next up is James Moxey from Wood Knowledge Wales. James, you're going to talk about zero carbon homes and zero carbon timber solutions. And one of the good things I think about this session is we've tried not to do it too niche. So we're not focused on infrastructure, we're not just focused on homes. We wanted a broader range of speakers today. So thank you, James, over to you.
Thanks, Paul. Hello, everybody. Thanks for the chance to present this work today. My name's James. I oversee a number of projects at Wood Knowledge Wales. Wood Knowledge Wales is a not-for-profit social good organisation supported by a substantial number of members across Wales from the supply chain, forest industries, offsite manufacturing in terms of timber, design, and a significant number of clients. So most of the RSLs in Wales, the housing associations in Wales, are our members. So I led the piece of work that I'm going to talk about today, which is itself part of the larger Homegrown Homes project. My background is in funding, establishing and running research centres with multidisciplinary research teams. So if I mention anything that's totally meaningless to you, or I'm using too much jargon, please remind me in the chat, and I'll do my best to change that. So the project was about developing a viable net zero whole life carbon solution to develop social housing for the Welsh demand and supply chain. This was a fantastic opportunity for us, and we were basically given the luxury of over 2 years to undertake research in how to deliver zero carbon homes at scale, mostly using timber and timber related products. So the context for the work is the climate emergency that we're all in, declared by Welsh Government and by all 22 local authorities in Wales. And of course, we can add many other organisations who have declared climate emergencies, including many of the clients that we work with. And the important thing is to take action in the face of these climate declarations, climate emergency declarations. So construction obviously has a significant role to play, not just in terms of the material choices we make, but in terms of our design decisions and our build methods and the consequences of these for the energy demands for the future, the energy needed to heat the homes. So this is a slide taken from the Green Age, which shows the predicted total energy demand of a small semi-detached house built in the 1930s, and it's predicting an energy demand of around 373 kilowatts per hour per meter squared. And I think that's a very important figure because our objective on our new build projects is to get that energy demand figure down to 35 kilowatts per hour per meter squared. That was our objective, one of our objectives. So our brief was to develop a net zero whole life carbon build solution. And when we say whole life, we mean the carbon emissions in construction, in sourcing materials, the construction, the manufacturing, and then the energy used within the home and the carbon footprint associated with that energy over a 60-year lifespan, and then also to take into account the end of life, so demolition and potential reuse of materials. We weren't planning on doing something radically new. It was really important for us to work with the supply chain and to focus on an evolution rather than a revolutionary design. And we wanted to reflect the build systems that are currently in use, and that there would be, and accepted there would be some evolution driven by a set of clear priorities. You know, we need to reduce the energy demand from our homes. We need to reduce the embodied carbon materials that we use to build homes. We've got to eradicate the use of fossil fuels to heat our homes. And really importantly, we need to do something about the performance gap so that what is built, it reflects what has been designed and modeled. And then when we've done everything we can to achieve these, then we need to consider the journey to carbon neutrality, or what we refer to as a net zero whole life carbon solution. And what does that mean? It means accepting that carbon will be emitted during the build process. What we need to do is to take measures to then capture carbon and store carbon as a form of compensation or a form of offsetting. So I like to think our activity and our research was totally collaborative, and we worked with a large number of organizations across the supply chain and consulted with them throughout the process, particularly with offsite manufacturers, MMC, and the clients for housing. So I was fortunate enough to assemble a team of experts with a wide breadth of knowledge across different disciplines, and they all did incredible work on this project. I know we shouldn't single people out, but I'm afraid I'm on this occasion, I'm going to. Rob Thomas, Dr. Rob Thomas is a friend of mine and a colleague who worked with me throughout to develop the research that we did, and you can download that report from our website at Wood Knowledge Wales. And I had the pleasure of spending many hours debating, discussing, researching, and fundamentally driving this project forward with Rob. So it's always a good thing to have a research framework within which to respond to when you're undertaking a project like this. And we were incredibly lucky that at the time we started, the UK Green Building Council had published a net zero whole life carbon framework. And this became a guide for us along our journey. And I'd argue that they led and continue to lead this agenda and provide a steer to other organisations, such as the Royal Institute of British Architects, who subsequently set some really challenging targets for us all to think about in terms of operational energy demands for the future for housing and in terms of embodied carbon impacts. So if you see there on the 2030 targets is what we were focusing on. We were trying to get the operational energy demand of our housing down to less than 35 kilowatt an hour per meter squared, and to achieve no more than to the impacts in terms of the embodied carbon of the materials that we use to be no more than 300 kilograms of CO2 equivalent per meter squared. That was incredibly challenging, but we're getting there, we believe. Subsequent to these targets, Wood Knowledge Wales and a team of colleagues from different partner organisations developed this, which is our own net zero whole life carbon framework for Wales. We put together a series of guiding principles here, do everything we can to minimise embodied carbon. We set ourselves a target of 300 kilograms of CO2 for upfront carbon, which is arguable, we could argue is our priority is to reduce carbon that's emitted now. That's our biggest problem, considering the timescales that are given to us. And also, as I said, to get energy demand to 35 kilowatts. Also, only use renewable energy. We need to stop using fossil fuels. The importance of minimizing the performance gap, and that's where our collaboration with the skills and education sector across Wales to work on making homes built as modelled and designed, and then an offset solution to below zero. As you can imagine, we're really interested in planting trees and increasing the amount of tree cover in Wales, and that's where we're focusing. And we say offset to below zero, so if you miss, hopefully you'll achieve zero. There's a level of tolerance there. You know, if we're going to genuinely respond to the climate emergency, we need to consider our total CO2 emissions in terms of building and living in homes. And as you can see from this diagram, 50% of carbon emissions take place before someone is handed the keys to move into a new home. And there's a relationship between material choice and locality as well. So this, we have a 1 mill in Wales processing construction timber, construction grade timber for home building, but a significant number of offsite manufacturers will source their timber from other sources. So you can buy Welsh and homegrown timber from most of the building merchants in Wales, and Jewson's particular. I don't have any liaison with Jewson's apart from occasionally buying their timber, but they sell C16, which is grown in the UK. But most of our offsite manufacturers tend to use imported timber for a number of different reasons, but we're working hard to try and make their sourcing more local and to address some of the challenges associated with that. But inevitably, we do use materials that we need to import because They're either not manufactured in the UK, or they have certain properties that give us the performance values that we're looking for. So this is, for example, a pro-passive board from Ireland, very difficult to get hold of at the moment because of Brexit paperwork. And wood fibre insulation is something that we're really passionate about, as well as blown-in cellulose. But this wood fibre is sourced from Germany, I believe, Gutex. So what you can see here is one of 5 closed panel fabric designs that we developed within this research project. And it's not a revolution here. That, like I said, this is what you might refer to as an advanced timber frame design. But it's important for us to look at the supply chain to see what they're currently developing, and make sure what we propose fits well with that. And a significant number of the products in this panelized system come from Wales or come from the UK, but there are some products that we can't source from locally, and that we do import. And it's interesting to note that our internal insulation there is a mineral insulation. The main fabric is composed of homegrown timber and wood fibre insulation, or blown-in cellulose in the fabric. So we developed a series of fabrics. Importantly, we did a series of embodied carbon assessments. As our previous speakers mentioned, Kathy, about science-based targets, we used embodied carbon assessment software, and we looked at as many EPDs as we could find to get the data behind what we were doing. And when we started modeling it, we realized that we had a benchmark product, which is what the industry tends to build or has been building, which has got a foam insulation. And when we analyzed our fabric designs against that, we were getting savings of around 75% in terms of embodied carbon. And this is all, as Kathy said, science-based. It was truly a fabric-first approach, and based on scientific analysis. So one of the more important findings for us was looking at the principle of form factor and reducing the energy demands of housing. We considered a whole range of variables: orientation for solar gain, U values of walls, and heat loss form factor. Which is the ratio of the thermal envelope surface area to treated floor area, this is a crucial piece of research, and the findings were really important for what's followed. What this diagram shows is that the smaller the form factor, going from right to left, means less energy demand or less U values required to maintain the same energy demand. This was a fundamental principle that we factored into our research, and then we also looked at the footprint of housing. So on the left-hand side is a footprint of a home that is currently a typical housing association 2-bed 4-person home, and we looked at it and we modified it in the design at the design stage and reconsidered it in terms of various different layouts. What emerged was a design around a townhouse, a 3-story townhouse, and we started considering these in the form of terraces. Now, the most crucial kind of outcome for us was this energy modelling, and we worked with our colleagues in Bristol, Greengage, who specialise in building physics. I think it's important to say I don't get very excited by graphs, I'm glad to say that, but this was pretty groundbreaking for us because it showed that with an optimized design, particularly this 3-story townhouse, with it demonstrated the potential heating demand. So I think what this graph shows is the top line is a detached townhouse. The next line down is a pair of semis, and as we go, it's more combinations of townhouses. So if we're looking at a terrace of 4, which is the 4th line down, with a U value of 0.1, which is incredibly challenging, it's around about passive house levels, but with a U value of about 0.1, the space heating demand is 10 kilowatts per meter squared, or total energy demand would be in a range of 20 to 25, which is well below REBA's target for 2030. If we could get to 25, we'd be smashing REBA's target well in advance. And this really helped change our thinking. So what's happened, you know, what our principle is, how do we get to zero? Well, on the left-hand side, this is like an equation. On the left-hand side, a terrace of 6 townhouses gives a carbon footprint of a certain amount. And we think we then offset that by 2 principles. One is to validate the carbon that's stored in the timber in the buildings, and that's something we're developing with Welsh Government. Carbon storage is a form of offset, and also then through a woodland planting scheme. When we've modelled it in our work, we estimate that to offset a 100-house scheme, we're looking at a cost of between 1% and 2% of the overall development cost to offset it through a small planting scheme, if we do everything we can to reduce the energy demand and reduce the carbon footprint of these buildings. So it's quite modest, and housing associations are now working with us to look at woodland creation schemes which benefit their tenants and benefit the local community, and also make a sensible investment for them financially. And actually it's quite a profitable investment over the long term. You know, housing associations have 40, 60-year business plans, which is perfect for a woodland creation scheme, which, you know, take that kind of time scale. The good news is, and to finish, the good news is that we're now working with at least 11 local authorities, taking this work to the next stage through an innovative housing programme funded grant. We've just submitted the report for that, and we've developed a draft technical manual for this townhouse, and we're hoping to work on a whole range of house types, applying this thinking as part of a council house building programme to build thousands of homes which address both the climate emergency and the challenge of delivering homes that the people of Wales need. Okay, so thank you very much, and I'll pass you back to Paul.
Thank you, James. Excuse me. That was really, really interesting, and I think the thing that stood out for me was that I think it was the 373 down to 35. That is bold. That must have kept you up at night. Just a quick sort of terminology thing, James. Do you want to just take a couple of minutes and explain the performance gap? Because I know it's really, really important.
Yeah, it's a fundamental issue for us. So we work really closely with our clients and with our members who are clients, like the housing associations and offsite manufacturers in Wales. And there can be small changes in the way certain products are installed that can have a significant impact on the kind of lifetime of that product and its ability to, you know, for example, if we're looking at rain screens or how they're attached to the fabric system or all aspects of housing. If we need to specify it correctly, we need to make sure the specifications based on the most up-to-date available technical and scientific way of doing these things. And then we need a workforce that is able to interpret that and then install those systems in the correct way. And I think that's what we're talking about in terms of the performance gap. You know, the classic story is we create a completely airtight building. Well, not completely airtight, but we're getting near passive house levels of airtightness, and then someone comes in and drills right through the membranes and creates a thermal bridge. So it's working together. There's no criticism intended. It's about working together, all sectors working together, so that we understand what needs to be done to get these high performing homes, and that's as much a pressure on designers as it is on skills and education.
Thank you, James. So the example as a layman I would always give is it's designed perfectly, and then the second and third fit come in, they can't quite get the pipe to fit, so they knock out a brick, fill it full of foam, plaster over it, and then you've got a problem. It's not going to work in the way that it was designed to work.
Yeah.
that type of thing. Okay, that's wonderful. Thank you. We've got some questions there. Just a quick shout out to Ian, who's asked an absolutely brilliant question. That'll come up in the Q&A. I'll go through that. So James, if you want to have a quick look at that. In fact, any of the other previous speakers, if you want to go through the chat and have a look at some of the questions that have come up, give you a chance to prepare your answers. Okay, so next up is Owen from Celsa. Owen, are you there?
Good morning. Yes, I'm here. Can you hear me, Paul? I take those yes. Excellent. Well, thank you very much for inviting me, and I think it's a bit of a pleasure to be involved with such a group of people looking at the amazing things happening in Wales. Well, my name is Owen Bailey. I'm the Innovation Manager for Celsa Steel, and so I just want to talk to you this morning a little bit about who we are, what we do, how we currently operate, and the environments and areas we operate in. A brief introduction into the circular economy and both Celsa's view and my personal view on the circular economy, and then an introduction into a pilot project that we ran with BAM Construction, and which is the project itself is finished. What we're doing now is correlating and calculating a lot of the information and data from that. But what I want to do is share with you the anecdotal story of how we've developed, how we've explored the project, and the immediate outcomes that we've found from it. So I'll kick in. Let me just see if I can make this work. Okay, so a little bit about Celsa. Celsa is so we make, just in case anyone didn't realize, we make steel. We make steel for industry, mainly for the construction sector in the UK. But we produce. By making steel, we turns out we are also a major recycler in the UK. So we actually recycle 1.2 million tons of scrap steel every year. We achieve this by utilizing an electric arc furnace. Our scrap is locally sourced. We know that we can quantify that 100% of our scrap is sourced within the UK, and with the exception of a couple of different raw materials, the majority, 98% of our feedstock is from that recycled material. Celsa is a family-owned business. We're based in Spain. It's owned by the Rubialta family in Barcelona, but as a family-run business, it certainly has a family values, and you can see there on the left-hand side some of our vision, mission, and values, which kind of aligns to a lot of the positive things we're talking about today. And we are a supplier to the majority of the major projects in the UK. So with that 1.2 million tons of scrap being recycled, we actually produced about 1 million tons of product, and that product goes out to the UK industries. From sourcing of the scrap material to the build within the UK, we can quantify that it's less than 500 miles have been travelled at this furthest extent, and ultimately, our products and processes are made in the UK to build the UK. In terms of EPD, we've quantified our latest EPD. We've quantified that a production of steel, a ton of steel is down to 647 kilograms of CO2, and you add transport into that, it's 653. In comparison to other European electric arc furnace steel producers, we're quite a bit lower, and ultimately, in terms of BOS, the oxygen furnace steel produced in China, for example, we're quite a bit less in terms of our carbon footprint of that. And based upon those details, we're certified to a number of different things. The eco reinforcement certification is something we're quite proud to be a part of, and we have a number of suppliers and steel users in that certification as well. If go to the next slide, so Celsa is an integrated steel producer. So in that sense, we are integrated into our supply chain. So we have scrap processing capabilities. We ultimately have the melt shop in which I didn't mention before, we're based in Cardiff. And anyone who's driven into Cardiff from the Newport side will be well aware of who we are and we are well aware that we exist, maybe not exactly knowing exactly what we do on those sites. But so we produce the steel with the 2 rolling mills we've got in Cardiff, and then we send out the rolled steel to fabricators across the UK. And listed below here are BRC, Express Reinforcements, ROM, and ROM Tech. These are all downstream operations that are under the CELSA family umbrella, and therefore we can deliver made products to site ready for installation. Just a little bit about the process in which we follow. So again, going through the melting of the steel using electric arc furnace. Anyone who doesn't know electric arc furnace, it's anecdotally, I quite like to use the word. It's just a lightning storm in a bucket. It's about 150 tons of scrap steel is put into a furnace where electrodes come down, and the energy generated, charged through those electrodes, will melt that steel within about 45-50 minutes. We refine. We have a second process then which refines. I'm going to apologize and put you on hold. My dog will bark. Sorry about that. So we refine the process, and any additives will go in to make sure we get specification steel correct, and then that the molten steel will be put through a continuous caster to produce billets. Now those billets get sent off to the 2 rolling mills we've got in Cardiff. One is the rod and bar mill, which produces the products as you see below, the rod and bar, rod, wire, and coil, and then the sections mill produces channels, flats, angles, and so on. So those 2 different types of products in the 2 different types of mills, and probably will go to the different areas of industry. The rod and bar mill predominantly will be sent off to be reprocessed either by our fabricators or direct to site as long lengths, and they would predominantly be utilized in reinforcement of concrete. Now, also just to talk about, we have the capacity to produce and process and deliver 900,000 tons of reinforcement within our site in Cardiff. All our rebar has a UK stamp to highlight the fact that it is a UK made manufactured product, and we are certified to provide materials into the nuclear industry. And yeah, we just again to highlight the fact that we are a major supplier into the UK, major iconic projects, and we're quantified to do so. So just a little bit about on our employment aspects. We're very much an advocate of apprenticeships and apprenticeship schemes. We are looking to increase the flow of apprenticeships through our process, and to include traineeships in that. We're seeing bonds, investor in people, and in terms of our kind of footprint within the UK. So in Wales, we employ, we support the employment of 3,500 jobs, and across the UK, then it's 5,500. Ultimately, we input about 189 million pounds worth of value into the UK economy. And just a little bit more about our engagement with communities. So I'm not going to list them all here, but we do engage with communities, and it's something we're looking to continue and progress on. And we also, in March this year, we signed up to the UN Global Compact as a group. So we're making steady strides forward into enhancing our environmental credentials and making sure that we are the steelmaker of choice. We also have a zero carbon ambition, and it's something we're in the process of developing our zero carbon pathway. I did question when my boss said to me one time that he had a zero carbon ambition. I questioned whether that ambition was strong enough, and suggested that we should look at potentially net positive in what we do and how we do it. But we are working towards that and moving in the right direction, I feel. One of the ways we are looking to do that, and I'll explain a bit more about circularity in a second, but we could be considered a circular economy company because we are taking a material, an end-of-life material, in scrap, and that material comes from all parts of industry, whether it's automotive, construction, white goods, for example, all of those materials, and then even local authorities. The material that is processed by us comes from all over the UK. Now because we produce a product from that recycled material, we're adding value back into the economy, the Welsh economy and the UK economy. But the trouble is we're doing what we're doing in the context of a linear economy. We're still very much a part of a linear economy is about the transactions between different organizations, very much a siloed approach to what industry does, what people do generally. And within that, we have to make sure that we are purchasing our feedstock input from the UK. But unfortunately, the UK is a net exporter of scrap metal, and we have to battle on the global market to keep that metal, that steel, in the UK. And so therefore, we're affected by the global market. We're affected by fluctuations in the likes of China and India and Turkey in terms of steel prices. We're also, it goes in line with the fluctuations around iron ore as well. So there's lots of elements that we need to consider when we are looking at our business and looking at what we do. And one thing we have to remember, within a linear economy, there's only ever one opportunity for any organization to make money, and that's at the point of sale. And so again, although we may be delivering circular solutions, we're still only able to ever make money like anyone else when we sell stuff. So with that in mind, I'm keen to look at and to explore how we as a business can function within a circular economy and build these restorative solutions. And once an organization starting to look at how they can deliver solutions within a circular economy, there's a lot more opportunities, and ultimately it's all done through collaboration with your supply chain, with your customers, and this is what we're trying to do. And the way I feel with that collaborative impact and that collaboration across industry, there's shared benefits, and I've listed some of those. But ultimately, it's about making sure that we have a future that is fit for future generations, and a society that's looking at things more collectively and more collaboratively. And so this moves on to our pilot project, and I'm delighted to say that this pilot project started life in over coffee at a supply chain sustainability school event in Cardiff a couple of years ago. And I sat down and had a conversation with Amanda Wright, who I believe is on the call. And we had a conversation about what we could do potentially together about the remit or the ambition from BAM Construction, what area they were looking to advance and to move their sustainability agenda on, and ultimately how we could support that as a business. And therein started our conversation about collaboration and exploring how we could come together as a combined collaborative solution for a project to start off with, and ultimately to look at how we can explore this. And I would say within a circular economy approach, there's always multiple opportunities for benefits, not just in terms of the cash available at point of sale, but ultimately how we can add more and more value back into what we do and how we do it. So this conversation I had with Amanda at the supply chain school event ended up being the Plaza Cinema project. And the Plaza, anyone who knows South Wales would know that in Port Talbot we have a pretty iconic kind of building in that it's the birthplace of a lot of famous actors from Port Talbot. It started life either visiting the cinema or I think it was a theatre at some point as well. But it's so this iconic building, built in opened in the 1940s, was stopped showing the films, I think 1999, and since then it's gone into disrepair and dereliction. So so the plan was that that BAM were taking over the project for the redevelopments, but through the conversation with Amanda at the event, we started looking at exploring what kind of materials were coming through that demolition process, and whether it was possible to explore providing that scrap material effectively to CELSA directly. So this is where we started to explore and have this conversation. There was some material that was able to be recovered from the project that wasn't able to be reused, but could be reprocessed. So we did so, and we ultimately delivered that recycled material back to the same site for the redevelopment and the rebuild of the new version of the Plaza Cinema Complex, which is effectively closing the loop on that steel. So circular steel is what we're trying to do, and be able to do that as a collaboration is something we've explored and achieved through this project. Some of the just a little bit more information about the project itself, the scope of works. I'm not going to go through them all, but we can share the slides. You can read through it. But I think the timeline is quite significant with the fact that the event took place in September '99, and by January 21 we had materials on site being delivered, and this is including a pandemic and trying to figure out how we work and how we develop this collaboration. If I go on to the next slide, just some of the drivers from BAM's point of view. And from CELSA's point of view, just some of the benefits that we could highlight based upon the material being provided. So 24.9 tons of scrap metal was provided by BAM, and it was the old roof joists that couldn't be reused as part of a circular economy, but could be reprocessed. So we took that material, reprocessed those 24.9 tons, and ultimately we were able to, in comparison to other producers across Europe, we're able to reduce the carbon footprint of that material quite significantly. And just to add as well, the UK Steel did an assessment on the value of keeping steel circulating, keeping steel within the UK. So it just highlights again that actually using a UK supply chain has benefits not just to the individuals involved, but the whole UK economy plays an advantage, or has an advantage by keeping that steel. So it's just to highlight that that's when organizations are building projects, to make sure that that's the supply chain uses UK resources, and particularly in our instance, Welsh resources. So I think one of the lessons it's worth mentioning, one of the biggest lessons that both Amanda and I learned through this exercise was that, and a bit of a shock actually, that we discovered how easy it was to make happen, how easy it was for a collaboration across the supply chain to come together and to work. Now, in a linear economy, we're very much transactional. We buy stuff, we use that stuff, and by producing something, and then we send it on, we sell it. Whereas we don't necessarily look the other way around. We don't actually look to collaborate down or back upstream and see where we can support and develop solutions. And I think the challenge really was around, and we still have this challenge, is the current way of quantifying a supply chain and current way of quantifying the sustainability credentials of a project, let's say, is based upon the scope 1, 2, and 3 emissions. And I still feel that although scope 3 emissions, individuals can't affect their scope 3 emissions directly, but they can if they start looking at working with the supply chain. But it's still not set up to facilitate a circular economy. So it's something we're keen to explore, how we can implement more radical changes to the process of quantifying this circularity. But I feel that if we can achieve something through circular steel, then it's hopefully a benchmark for others to come together to look at how we can design for these solutions. The other thing to mention is that, and the way I feel this collaboration going, is that once we we developed this foundation, let's say, that we can start to explore new opportunities of how to enhance the whole concept of circularity. And so therefore we go from looking at reducing our overall footprint to becoming net zero, but ultimately adding a lot more value, so becoming positive in what we do. And it's just, I think it was a really interesting exercise to go through, and something I'm keen to replicate on a larger scale and other collaborators. And just a bit of a shout out to a project that a number of us are involved in, including Rockwool, is the South Wales Industry Cluster, and this is a combination of a number of organisations in South Wales coming together to look at decarbonisation as the main focus of this, and particularly those hard to abate industries like steel makers and oil refineries and so on. But it's how we can come together to develop the concept of circularity is something that I'm passionate about, and I'm passionate about delivering within this context as well. And I think in doing so, we can start to redesign effectively our economy, redesign who we are and what we are as a nation. But ultimately, we need to be doing things differently. We need to have a future that is much more circular, and an economy which is circular by nature. Because I think as good as we are at reducing our overall carbon footprint, and I include the likes of electric vehicles and wind turbines in this, but if we don't understand how those things are made and ultimately what happens to those materials at the end of life, and if we don't look at designing more systemic solutions, then we're going to continue down a path that's not going to be beneficial to anybody. Whereas circularity, I think, is certainly a way forward. And that's me. I think just one thing to end on, and something again to highlight what I feel we've started achieving with BAM, is that collaboration is key to a restorative circular economy for future generations. And I think we are in a really strong position as a society to be able to do this more effectively. That's me. Thank you.
Thank you very much. That was a wonderful presentation. Really big food for thought there on collaboration, and what a great example of collecting scrap metal in Wales, repurposing it in Wales, and putting it back into a building in Wales. Absolutely fantastic. Could I ask? We're going to do a bit of a Q&A now. Could I ask all the speakers to put their cameras and their mics on? I think we're allowed to have 4 on, so we should be okay. Okay, I suppose I will go through the message board in a moment, because some of them are quite detailed and specific. But if I just want to throw something out, and everyone dive in here, is there's often a perception that looking at these things, trying to reduce carbon using different materials, it's the expensive option. I suppose my question is it always the most expensive option, or actually can you save yourself some cash as well? So I'll just throw that open to the speakers there. Who wants to dive in?
Well, if I look, my background is in design. I've been designing cars and aircraft interiors for many years, and designing systems. And we can design whatever solution we require, but we need to understand the scope in which we're designing it. And I think from personal experience and what I believe, that none of this should be more expensive than doing it the wrong way. Because ultimately, if we're not designing in sustainability, we're not designing sustainably. So I think there's no reason why any of this should cost more money than anything else. In fact, it should. If we look at resource efficiency across a region and across an industry, we should be able to reduce costs, not increase them.
Excellent. Anyone else?
Yeah, I'd like to sort of bring up the example of zero carbon homes. So many people on the call may remember there was a target that all new homes would be built zero carbon by 2016, and that target was set years in advance. So the whole industry knew what we were working to. And there was a big price gap between standard houses and zero carbon houses at the outset of that. But you know, a number of different groups started working together on different methodologies, different designs, new ways of constructing. And by sort of 2015, we were able to make Code 6 houses for roughly the same cost, or maybe £1,000 or £2,000 more than standard build houses, because that goal was set so far in advance, and we were able to work together and come up with new ways to achieve that target without loading extra cost onto the process. And it was really unfortunate that that policy got scrapped at the last minute, and you know, we're sort of you know, another 5 years on, and we're still not building zero carbon. You know, we know where the end game is. 2050 will be zero carbon. All the buildings that have been built, 80% of the buildings in 2050 are projected to be buildings that already exist, and all of those buildings need to be upgraded now to meet that ultimate goal. You know, you sort of load in cost onto the future if you're not doing it right from the beginning.
Thank you. That's really interesting. Anyone else? Who'd like to add to that overall point about cost versus benefit?
I would add that I agree with what people have said, and I think if we can start building at scale, you get the benefits of that, the economies of scale. We're looking at standardized solutions from an off-site manufacturing point of view to help with that as well. There is an uplifting cost, but we're not comparing like with like. You know, if we're comparing traditional ways of doing things with delivering net zero whole life carbon, because there's different flavors of net zero out there as well. So within a net zero context, it isn't more expensive. But if you're comparing it to the way we have built, maybe there is a small uplift. But cost, I think we need to start using the word cost in terms of future generations, cost to future generations, as much as what's going to cost us now financially, because we're talking about the future. You know,
I just sorry to cut in there again. I think one of the things we need to do is consider value, not just cost. Cost is a fabric of a linear economy, whereas we need to look at value, and value across not only a project but a life cycle and over time as well. And I think that's something which I think we're lacking in terms of the true value of things. And then procurement policies, I think, are renowned for focusing on the cheapest price and cost, whereas we need to start procuring value and making sure that we procure that value through collaboration.
Yeah, if we're thinking about future generations and we're in a climate emergency, that is the context. And I think, you know, how do we factor pounds and euros into that conversation when we're thinking about, you know, a global warming? And that's the magic solution that fits to that is something that we've got to all discuss this together. It just can't fall on Welsh Government. I know there's a huge amount of pressure on funding from Welsh governments, particularly in terms of housing, the social housing grant, and whether that's enough to deliver net zero whole life. But it's a challenge we all work together to address. I think it needs to be across the supply chain, not just looking at Welsh Government, for example.
Brilliant. You said all the things that I was about to say about value, and also how procurement, let's face it, needs to change in some areas. I think it's fair to say. And I think you touched on it, Owen, in the sense that one of my other questions was how important is design in designing out carbon of your products or your processes?
I think we there's maybe some misconception or misunderstanding that design is something a designer does. We're all designers. We're all responsible for designing our day. We plan our day out, for example. So everyone's responsible for designing something, and so we need to be able to understand how, when we design whatever we design, we look beyond the context of just selling more stuff, and look at it from the perspective of full life cycle understanding, a full systems approach to the solution as well. So it's everyone's responsible for design. It's not just designers.
That's right.
Okay, thank you. Anyone else want to add in anything around design?
I just wanted to add, I'm fascinated with where everybody's presentation was fantastic, particularly steel. Recycled steel is something we should seriously look at as a community, and its potential for, especially if we're turning, if those arc furnaces are powered by renewable energy, it changes the landscape, doesn't it? We're interested in hybrid solutions, timber steel. Hybrid solutions.
I think so, and I think it shouldn't be one or the other. It should be kind of a combination, and again, a systems approach to the solution. I think one of the things that may be worth mentioning that CELSA has, we're constantly trying to guarantee that the energy we use is 100% renewable. Now, the makeup of the current network isn't allowing us to do that. But I think one of the key things to consider from government to consider, at least, is the cost of energy in comparison to other European countries and global countries, global networks. We're at a massive disadvantage in the UK, and hence the reason why it's difficult to compete then with outside source of supply chains and resources coming in. Because we haven't got they may not have the same energy costs that we have in the UK. So it's something that we need to address and try to address, and we're trying to on a constant basis.
Okay, thank you. I should just add at this point, if everyone would just have some forbearance with me, that if you go to the supplychainschool.co.uk, there are loads and loads of free resources on this topic around carbon reduction, around materials. I mean, essentially everything you want to know about sustainability. So please do go on there, do an assessment, understand your strengths and your weaknesses around sustainability, and do use those resources that our partners have helped to fund. And again, also, if you want to become a partner to the Supply Chain School, I don't know, Welsh Water, Anglian Water, HS2, Waits, Morgan Sindall, and many, many other organisations. I think we've got 126 partners now. Do drop me a line, paul@supplychainschool.co.uk, and we can have a chat about that. I'll certainly be catching up with a few people who've been on this call today about getting you guys involved. If I just go to the chat function, and also while I've got you, I've got to ask Catherine, where do you get your volcanic rock from? This is the first question I wanted to ask.
In the UK, we get it from Northern Ireland.
Wow, okay, fantastic.
So it gets shipped across, yeah.
Okay, so I think this one was for Laurie. Does Concrete Canvas currently have DWI approval? I don't know what that is, Laurie, I hope you do.
Drinking water inspectorate. No, we don't, not because the material adversely affects water. It's more that the material, once it's hydrated or during hydration, the Drinking Water Inspectorate deemed that the amount of small particles released off the surface of the material meant it couldn't be, I think it couldn't adhere to Article 6, I think was the reasoning. However, once the material has set, it's like it is concrete, so it adds nothing to the water.
Right, yeah, I remember that part of your presentation. Okay, thank you. The next question, when comparing logistics and installation between the two types of concrete, you mentioned you only needed a pallet load of the concrete canvas compared to 2 6-ton trucks, but it looks like you had to take a truck to lay it. Was this factored into your carbon savings? Detail one.
Right, so during installation, we've got different formats. Now the bulk roll, the big rolls, they weigh 1.5 tons. You'd need a excavator. So our carbon footprint, as it were, during installation was considered, yes, for the use of machinery. However, when I compare 2 6-ton concrete wagons to one pallet, I'm more comparing the logistical footprint for transport, and then on site you wouldn't need that amount of machinery to lay the material. For example, you take a local project, the A55 or even the M32 outside Bristol, or the A14, you need an excavator and 3 men. That's really all you need.
Oh yeah.
You know, so I'm putting my email in the chat function. Please get in touch with me. I can forward on the full Ricardo Energy report, and it goes into detail how it's assessed our life cycle analysis and the global warming potential from, as I've said, during upstream, so sourcing, production, and also installation and use. So
okay,
please drop me an email if you would like more information. The report, I've just put my email there. Also, the gentleman who asked about the DWI certification, if you have a specific project, or just please drop me an email. I can discuss it further. We currently, just yesterday, I was on the Welsh water site in Hereford at Bromyard. We are specified by whichever designer it may be for utilities projects. So if it's with regards to a utilities project or something similar, please get in touch.
Okay. Catherine, can rock wool be recycled at the end of a project?
Yes, the product is recyclable. We take it back for recycling, and it can be recycled without loss.
Okay, thank you. And the other supplementary is, are you looking into any other insulation products?
Not currently. We are driven by a purpose, which is to release a natural power of stone to enhance modern living. So everything that we do is based around stone wool, but we do use an abundant natural resource, which is constantly regenerated from within the earth. 38,000 times more stone produced by volcanic activity every year than we use in our processes. So yeah, we're not currently materials.
Okay, and I think there's a question, I think this one was for you. Do you have available EPDs for your products?
Yes, we do. We had a new one published in March, so if you get in touch with us, we can share that with you.
Lovely, thank you. What further? I'm going to ask that question a bit later anyway. So, do you offer a take-back scheme of material offcuts?
Yes, we do. So it works differently for different customers. I think we are sort of looking at refreshing the process, but it doesn't tend to be a one-size-fits-all. So particularly where customers are sort of based quite locally to site, and we're supplying regularly to them. For OEM type customers, we have these kind of circular routes where we drop off material and cover offcuts. But from construction sites, it works slightly differently. But if you get in touch with us, we can set up something that works for you.
Okay, thank you.
Sorry, in case that was also for concrete canvas, because we do get asked that. We for offcuts, we don't offer take-back scheme. However, as mentioned, the bulk rolls or even batch rolls can be cut exactly to size on site. So typically, the amount of material that's left over is negligible. I'm talking like single-digit meter squared.
Sure. Okay, that's wonderful. Thank you, Laurie. I thought this was a really interesting question. I know, James, you've answered it in the chat, but I just wanted to bring it to everyone's attention because this is quite an issue, I think. Going forward, are more Welsh mills going to be able to supply construction-grade timber from home-grown sources? So the issue here is, because this is all about supply chain resilience, working with our companies that are local to us. James, would you just expand upon your written answer, please?
Yeah, they definitely can provide construction timber. It's kind of the scale that we're talking of. So most mills, there are different flavors of mills in Wales, for small one-person mills up to the likes of BSW at Newbridge, or Pentrolais, which is just inside the border with Hereford, but it provides lots of timber for Wales. So Pentrolais and BSW provide construction grade timber at C16 mostly, but they also provide other products like decking, etc. If we're talking about building homes at scale across Wales, we're talking about a mill that is up to date with the most efficient technology that can produce at the quality and the price point that is needed and deliver in a timely manner. And so you're talking about a different type of mill. You know, we're competing with mills in Sweden and Austria and other parts of the continent where they've got that investment and the capacity. So we're the second largest importer of timber on the planet after China in the UK.
Wow.
So, you know, but there are smaller mills that can produce construction timber, but more for bespoke projects, and probably not able to deliver the kind of scale that the timber framers are looking for. They're producing 60 houses a week. You know, they need lorry loads of timber going into the sites at a speed and a cost and a quality. And there's nothing wrong with homegrown timber in terms of quality. It's that processing that we need to resolve. So I don't know if that answers the question effectively, but it's about scale and it's about investment. But one thing that is really clear, the price of timber is shooting up day by day. It's becoming very, there's a lot of demand for timber across the planet, especially in America. And so timber is being sold in large quantities into the US at the moment, and the prices are going up.
Right, okay, thank you. Just going through these. I suppose, James, I would also ask, where next with your project?
Yeah, so thanks. We're working. It's merged into what we're calling the Council House Building Programme. So we've got 11 local authorities we're working with. There's 22 in Wales. We're working with half of them on developing potentially a pattern book of house types, which use a limited number of fabric options, but also we're focusing on the kind of houses that the local authorities want to build, and we're doing all the energy modelling. Our ambition is to do the energy modelling and the embodied carbon assessments associated with those, so that we can give, as Kathy said, we can give that kind of science-based, evidence-based solution that describes how we've done everything we can to reduce the carbon footprint of these builds. But then to get to zero, we do need some kind of compensation scheme. And we're hoping that will be a woodland creation project to allow those homes to reach net zero. So we're in negotiation. We've completed one phase of that project. We're in negotiation for the larger phase of that. There's many other spin-offs from this project where, you know, involving community development, skills projects, and developing woodland creation projects in communities. But that's, you know, that's another whole story.
Okay.
Paul, sorry.
Yeah, go on.
I've got a question for James, if that's all right.
That's fine.
Just in terms of just the project evolution, you mentioned the evolution in your presentation. I'm just wondering, is there any consideration for an active building, or for buildings to be more active? Because we're talking about passive, and we talk about passive house, and to me that's just a benign structure to keep the rain off our head. We want our solutions to be active, and also then another aspect to that is service, and rather than buying more stuff, providing that stuff as a service is kind of different ways of looking. I'm just wondering if there's anything like that being considered when you're
working. Really interesting question. I think it boils down to renewables tech, and from our point of view, the jury's out on renewables tech. You know, we need to see the EPD data on renewable tech to make any clear decisions. You know, you've got a decarbonizing grid, and you know, if we're putting lots of solar panels and batteries in our homes, how does that square with a grid that's decarbonizing quickly? So we haven't made any clear decisions on active, you know, energy solutions. When we say passive house, we're talking about a home that is very airtight, that uses a fraction of the energy it needs. So we focus on fabric. Make that building so high performing that you need very little energy to heat the water and to heat the home. And also it's a very effective form of heating, so that we're not turning our boilers on full on in the morning to heat a cold house and then maybe doing the same in the evening. It's just a gentle heating process, and we keep a consistent 21 degrees throughout the home. Now, we're not looking to build passive houses. We're just using the thinking to design our homes. But so passive house in that sense means high performance homes in terms of carbon, embodied carbon, in terms of energy. But yeah, we're not speccing a renewables solution at the moment, whether it's solar panels or air source heat pumps and all this stuff, because the picture is not clear in terms of the actual carbon footprint of using that tech. And I think, you know, we need to do a bit more work around what is the most optimized energy solution in terms of its carbon footprint and in terms of cost. There are real issues with tenants having huge heating bills at the moment where they maybe not use it, where they're using renewable tech. So we haven't, I'm sorry, I'm waffling, but I'm not, we haven't gone down that road yet, and we haven't made a final solution on where the energy is coming from. But one thing it won't be coming from is from gas and oil. Definitely.
Okay. Sorry, go on.
Can I just add something to what James was saying there? We're also very much on board with passive house technology, or sort of design methodology. So we were involved in an NFIT project, which is the passive house refurbishment standard. We took an existing sort of 1970s concrete block and brought it up to date. We did some post-occupancy monitoring. Well, it wasn't quite occupancy because the occupants remained in situ during the refurbishment, but we put in temperature monitors inside to measure the performance of the apartments afterwards. And in the winter, when we had the beast from the east, generally heating demand was reduced by 90%. Across all of the tenants, and in some flats the heating wasn't turned on at all, but the internal temperatures remained above the sort of World Health Organization indoor temperature limits for sort of healthy homes. So I think that's really important. I think when we're talking about low carbon heating and energy efficiency, there's a whole other area of fuel poverty which needs to be dealt with and sort of intersects with a lot of this. And if people are in fuel poverty, they're probably not turning their heating on. It doesn't matter what the source of the heating is, they're not turning it on because they can't afford to. So if we can sort out the fabric of the buildings, that the heating demand is very, very much reduced, then the sort of impact of living in a cold home, the sort of health, physical and mental health impact of that, the educational payment, which isn't reached by the children in these environments, we can deal with a lot of that by sorting out the fabric, and then the energy sort of comes a bit later.
Yeah.
Okay, we've got a technical one here. Owen, what's your sustainability plan for your vehicle fleet with the miles traveled greater than 500 miles? Sorry, it's a bit of a technical one.
That's fine. I can't give you a technical answer, but I can give you. It's something we're considering, but the thing is, we don't own our fleet. We procure a service, and so part of our procurement policy, or at least reassessing our procurement policy, is to go back in and buy a more sustainable service. Now, also what we're looking to do within the cluster is be able to assess, part of the kind of ongoing discussions is to assess fleet systems within a cluster and be able to develop collaborative solutions around that. So there's nothing we can control directly ourselves other than through procurement, but I'm happy to have a conversation with anyone who has solutions or can work with us to develop those solutions. Again, I think hopefully it was coming through my presentation, is that what I'm keen for us to do more and more is collaborations, develop collaborations, because I think that's the only way we're going to progress beyond the linear trajectory that we're currently on.
Brilliant, thank you. And sorry, I've danced ahead there, and now desperately scrolling back to a question about PAS 2080. Do you have any experience of putting that in place, anyone? Okay, that's a no. Sorry about that, everyone. Okay, I'm just galloping through the questions, and I think I've. Oh, James, interesting one for you. In terms of you're looking at housing. What about schools? What about larger buildings? What about scaling it up? I imagine you want to focus. You want to fix homes first, but go on.
We are focused on housing, but we'd very much like to look at schools and larger buildings. We've kind of looked at low-rise developments as in a context of housing, but the principles are very much the same in terms of the thinking about energy demand and embodied carbon. We can use the same tools to rethink. So the principles are very much the same, but not currently, but we would very much like to.
Okay, and of course there's one here about global demand for timber. That might mean more deforestation. James, you will know the answer to this, and I would say that if you go to the supplychainschool.co.uk, there's loads of learning about how to source timber sustainably. But James, if you just give a quick minute on sustainable timber sourcing.
Those two questions are so interlinked, aren't they? I think the way to avoid the first one is to make sure, the way to avoid deforestation is to make sure that when you source timber, it comes from sustainably managed sources, and they should be certified, you know, with things like FSC. So it should have certification to say it's come from a sustainable source, and the sustainable source will guarantee restocking as timber is harvested, and that's part of the certification. But there is a danger, absolutely, with the demand for timber. Interestingly, Russia has stopped selling logs into Europe. It's now starting to build its own mills to provide timber into Europe rather than logs to be turned into timber into Europe. So, you know, this is all growing as a market and things are changing radically. But we need certification to guarantee that when we use trees, we restock them and we replant. Yeah.
Okay, thank you. It's a bit of a hobby horse of mine in that I think sometimes timber is viewed as one of the areas around sustainability that's been fixed. It hasn't, and you've really got to focus on where you purchase your timber and whether it's got the correct certification, because there is some rogue timber out there, and I've seen the presentations. Believe me, some of it's nasty and comes from very unsustainable sources. Just a final one, it's about your recycled steel used for scaffolding. Owen, anything?
I'm just about to respond to Vanessa.
Okay.
So we don't. I think I don't know much about scaffolding steel, other than the fact that there's probably a different specification of material to the one we produce. So no, we don't produce that steel. Plus, it's tubes, and we don't have the facility to produce tubes. What I was adding to that is that we can recycle that material. If at any point scaffolding is no longer usable or safe to use, we can process it and convert it back into a structural steel or a rebar. And I think she also asked about circular economy case studies, additional case studies. There's not many. Well, there's a few smaller case studies in the construction sector. In the steel sector, it's there's different opinions about what circular economy is, and even my own colleagues at group level are talking about circular economy as recycling of byproducts. And I keep telling him that's although it's positive, we need to do those sort of things. Recycling is not necessarily circular economy. So it's, although they come hand in hand, the circular economy is very much about a strategic designed approach to solutions as opposed to a reaction to a linear economy. So there's lots of different case studies to highlight across different industries of how circular economy is going in the right direction. And there is a transition required between where we are now and where we need to be. And certainly recycling and an industrial symbiosis, for example, is a way of moving that forward. An example of our own industrial symbiosis, we produce, as a byproduct of our process, we produce slags and dusts and so on. So we can capture the dust from our process, and in that dust is going to be zinc. So we can recover the zinc, and that zinc can be reintroduced back into industry. And also the black slag we produce, it can be used as we use it as road surface aggregate at the moment. But if we can get the specifications right and continuously get that specification right, it could be used as a feedstock into Rockwool's process. So again, these and other mineral wool processes. So we are constantly exploring how we can make that happen and make sure that we can guarantee that continuity of supply is possible. So there's what I was about to say to Vanessa as well, like if she wants to give me an email, we can arrange, and I can arrange a discussion. I'm happy to share other case studies with her as well.
Thank you very much. Okay, we're on 11:56 now, and I did promise everyone that we'd get away by 12, so I'll wrap up now. First of all, I would, if it was pre-COVID, I would be asking for a round of applause for all the speakers. So if you could just accept that, we're all giving you a round of applause right now, because that was 4 brilliant presentations, 4 brilliant companies working in Wales, employing people in Wales, contributing to the Welsh economy, and I think, you know, the Welsh government's push around supply chain resilience is really, really important. So thank you very much. Second, if you want to know more about these topics, please go to supplychainschool.co.uk. There's lots and lots of free learning there. Please do get involved and get those resources. Come along to our events as well, of course. And finally, if you want to get even more involved with the other 126 partners that we've got, all pushing sustainability through their workforces, through their products, through their supply chain, do get in touch with me. So at that, I will say thank you all to the 105 people who turned up. Now, we do need your feedback, as Rosie has just advised me with the slide. Please do fill in the feedback. If you've enjoyed today, let us know. If you want us to change it around a bit, let us know. Do click on that red button there for your feedback. It's really important to us, and Rosie gets into loads of trouble if we don't get any completed. So please do fill it in and let us know what you think about that. So I'll just say thank you again to the speakers, and I'll close the session now, Rosie. Thank you.